Today we're going to talk about comparing and ordering integers. So first off, to be able to compare and order, we need to understand inequality signs. So when we compare rational numbers, we write inequalities. And inequality is going to use one of these three symbols. So this symbol right here represents less than. Okay, so that means that the number on the left is smaller than the number on the right. This sign right here is the opposite of that, so instead of less than, it is greater than. So the number on the left, because we read left to right, is greater than the number on the right. And if you notice, our greater number would be here, which is next to the big gap, and here would be the bigger number, which is next to the big gap, if that helps you, right? The gator jumps and eats the bigger number. And then we have our equal to sign. So a couple things to think about. If you need to utilize this number line to help you, that's fine. As you move to the right, your numbers get bigger, they're greater than. As you move to the left, your numbers get smaller or less than. And then there's a few helpful hints to think of. Sometimes it's tricky, depending on what numbers are given to you, but sometimes there's little quick hints that can help you answer the problem quicker. So numbers that are further to the right are greater than the numbers that are further to the left. So if you're to the right, your number is going to be bigger than something further to the left. Okay, the reverse of that, if numbers are further to the left, they are less than numbers that are further to the right. So if you've got a number over on the left versus one on the right, that one's going to be less than. So I sometimes remember L in left for less than. And then if you have a positive number compared to a negative number, positive numbers are always greater than negative numbers. So we put kind of the sign here. If you've got a positive on the left, it's going to be greater than a negative. Or the reverse, negative numbers, if you have that on the left, are always going to be less than positive numbers. And then to note, negative numbers are always less than 0, right? We've got 0 right here. Everything to the left of it are your negative numbers. And then remember, when we start ordering these, negatives are opposites. Okay, so negatives are opposites of positives. So it is important to note that a bigger negative is actually a smaller number. Think about temperatures. Negative 50 degrees is actually a really, really, really cold number in comparison to negative 1 degrees. All right, so number 1, answer the following questions to compare the integers 5 and negative 7. So first we're going to plot those. So I'm going to plot 5, and I'm going to plot negative 7. So I'm going to look at this. Circle the correct word, 5, which is right here. Okay, is that to the left or the right of negative 7? So 5 is to the right of negative 7. Okay, well if 5 is to the right, it is greater than negative 7. So complete this inequality. 5 should be greater than, we use this inequality sign. 5 is greater than negative 7. All right, Saturday's temperature was negative 4 degrees Fahrenheit, and Sunday's temperature was negative 1 degrees Fahrenheit. Compare the integers. So again, we're going to plot these on here. So I'm going to plot negative 4, and I'm going to plot negative 1. So negative 4 compared to negative 1, it is to the left of negative 1. Remember, left means less than negative 1. So less than means the same thing as colder than, right? So the further to the left, the colder the temperatures are. So complete our inequality. Negative 4 is less than. We use the less than sign, okay? The point should be by the smaller number. The gap is by the bigger number. Number 3, answer the following questions to compare the integers negative 26 and negative 23. So this number line doesn't have it all spaced out for us, so we got to be careful when we are plotting, and I'm going to label where they are. So 26 and 23 should fall between negative 20 and negative 30. So I'm going to count. Negatives go backwards. Negative 21, negative 22, negative 23. And I'm going to write that on there so it's going to help me compare. And then negative 26, so 21, negative 22, negative 23, negative 24, negative 25, negative 26. Okay, so negative 26, is it to the left or to the right of negative 23? It's to the left. Left, that L means less than. It's going further into the negatives, it's a smaller number. So negative 26, we got to use our less than inequality sign. It's pointing to the left where the numbers are getting smaller. All right, we're going to compare negative 15 and negative 20. So again, we don't have everything labeled on the number line, so I'm going to count. Negative 15 should be between negative 10 and negative 20. So I'm going to count backwards. Negative 11, 12, 13, 14, negative 15. And then negative 20, we do have labeled here, so I'm just going to mark it right there. So negative 15, it's to the right side of negative 20. So if it's to the right, that means it's greater than. It's the further to the right, the bigger your numbers are getting. So negative 15 is greater than negative 20. We're also going to get some problems that have absolute value. So we got to think back to lesson 3, talking about absolute value. What does that mean? So the absolute value of negative 1 is the distance a number is away from 0. So how far is negative 1 from 0? It is 1 away. I'm going to show my work underneath. Okay? So if it's 1 away, the absolute value of negative 1 is 1. I'm going to plot that at 1 on the number line. Okay, well now we have the absolute value of positive 1. Well, how far is positive 1 away from 0? It is also 1 away from 0. So the actual answers that we're looking at are 1 and 1. So if I try to plot this one, well, I already plotted it. So the absolute value of negative 1 is in the same spot as the absolute value of 1. So does that mean it's less than, greater than, or equal to? If it's in the same spot, it is the exact same number it is equal to. So the absolute value of negative 1 is equal to the absolute value of 1. Let's try another absolute value problem. So answer the following questions to compare the absolute value of negative 7 and the absolute value of negative 6. So remember, the absolute value of negative 7, how far is that away from 0? It is positive 7 away from 0. So I'm going to plot that. 1, 2, 3, 4, 5, 6, 7, and I'm going to label that. Okay. Then, and maybe I'll label it what it actually is, the absolute value there. Then the absolute value of negative 6. How far is that from 0? It is 6 away from 0. So 1, 2, 3, 4, 5, 6 is looking at the absolute value of 6. So, absolute value, sorry, this was the absolute value of negative 7. The absolute value of negative 7 is to the right of the absolute value of negative 6. That was a negative, sorry. So that means the absolute value of negative 7 is actually greater than the absolute value of negative 6. So the absolute value of negative 7, we use our greater than sign to the absolute value of negative 6. All right, number 7. Answer the following questions to compare the integers 3 and negative 5. What does that mean? Well, let's start with 3. So 3 we're just plotting. 1, 2, 3. I'm going to label it. Now for this one, remember, inside the parentheses we have the number negative 5. When we add this other negative here, that means what is the opposite of negative 5? Well, the opposite of negative 5 is positive 5. So I'm going to plot that here. That is the opposite of negative 5. So when we're looking here, 3 is to the left of this value, of the opposite of negative 5. So 3 is less than the opposite of negative 5. So our sign looks like that. All right, now we're going to look at ordering integers before doing a you try on your own. So, friendly tip for ordering integers, start with the negative. So we're going to highlight the negatives first. And we need to remember, bigger negatives are smaller numbers. They work in the reverse way of positive. So I'm going to go through. That's a positive. Here's a negative. Positive, neutral, negative, negative, positive, negative. So I'm going to start with my negatives. My smallest number is going to be my biggest negative. So what's the biggest negative? Negative 12, negative 7, negative 20, or negative 11. Negative 20 is our biggest negative, so it's our smallest number. I'm going to cross it off when I'm done with it so I don't accidentally use it twice. Okay, now from the negatives that are left, what's our biggest negative? Negative 12, negative 7, or negative 11. Negative 12 is our biggest negative, so that is the next smallest number. It's the furthest to the left. Now we've got negative 7 and negative 11. Which one's a bigger negative? Negative 11 is, so that is the smaller number, which means the last negative here will have to be negative 7. Now before I get to the positives, the number 0. Remember, 0 is our middle ground. It kind of divides between our positive values and our negative values, okay? So, for ordering, 0 should be in between our negatives and our positives. So I'm done with 0. Now I'm looking at my positives. My positives work in the normal way. So 14, 8, and 3, which one's our smallest? 3 is the smallest, so I'm going to cross that off. Now between 14 and 8, which one's smaller? 8 is smaller, which means the last number will have to be 14. Okay? Go ahead and do the you try on your own.